In this video, we're going to hit the highlights of Chapter 2 of the Openstax Statistics book. So we're going to cover descriptive statistics. Our objectives are to display data graphically and interpret graphs, stem plots, histograms, and box plots, recognize, describe, and calculate the measures of location of data, recognize, describe, and calculate the measures of the center of data, mean, median, and mode, recognize, describe, and calculate measures of the spread of the data, variance, standard deviation, and range. So first we're going to look at something called stem and leaf graphs or stem plots. Then we'll just explore a little bit with line graphs and bar graphs. So for stem and leaf, often teachers use these to lay out the scores, for instance, or other kinds of things. You'll see what it looks like in a moment. But we need to divide each observation of data into a stem and a leaf. The stem consists of a final significant digit. So it's really kind of laying it out like according to place value. For example, 23 has a stem of 2 and a leaf of 3. The number 432 has a stem of 43 and a leaf of 2. The stems are in a vertical line from smallest to largest. There's a vertical line to the right of the stems. The leaves are increasing order next to their corresponding stem. And we're going to use technology, but you could do it out by hand if you wanted to. But technology lays it out really nicely. So we're going to use Staplet. So if you want to get that opened up, if you're able, it might be helpful to have your video going on your phone and have the PowerPoint open or the notes sheet. I've made like an outline to use easier as you're taking notes, or you could print that as well instead of having a whole bunch of PowerPoint things. So here's the data that we're looking at, and you can copy and paste it. I already have it separated out by spaces and commas. Originally, it came with semicolons, and I just highlighted that and edited it to replace the semicolons with commas so that it would be easily taken into the Staplet program. But a lot of times when you're working on the real data that we're collecting, it'll be on an Excel spreadsheet, and you can just like highlight the entire column and put it in there. You don't need to have commas in Staplet. So we're going to create a stem and leaf graph for the following data set for Susan Dean's spring pre-calculus class. Scores for the first exam were as follows, and they're already sorted smallest to largest so that it's easy to see, but if they weren't, you may want to do that. You could put it in Excel and then sort. I think that's one thing Staplet doesn't necessarily do well. So I'm going to switch screens here, but you might want to jot down that you're going to click on the one quantitative variable single group, and then you're going to put in the raw data and use the drop down menu, and we're going to begin analysis. So I'll model how to do that, though you may have seen that before. But if you feel like you want to try it on your own, go ahead and pause the video and work out this problem and see how it comes out. Okay, so what I've done here is pull up Staplet. You could click this link. And then I wanted my PowerPoint to still show so I could grab the numbers. So I hit my window on my screen, or you can just use the box up here to shrink your screen and kind of get two windows going on your one screen. Or again, you could just use your phone or whatever in conjunction. So we want to hit one quantitative variable, single group right here. That pulls it up in Staplet. I'm going to write the scores for the first exam. I'm just going to actually copy and paste, but you can just type that in. I like Staplet because it has the score titles that, and labels that we want. We want raw data. And now we're going to highlight the data. Be careful that there's no comma inadvertently at the end there, because sometimes that messes it up. So I just hit Control C, Control V, paste that data in, and then I click Begin Analysis. And now I'm going to make this side a little bigger here. And what you can do, or what you will see, is the dot plot pops up first, which can give you some good information too. It just tells you like there's, what the individual scores are, and it stacks it up. It doesn't really tell you the number on the side like other tools do, but you can count them up. 1, 2, 3, 4. So like we could see here, the most is 94. And we also have our summary statistics that you may have seen in chapter 1 already. So there's 29 values, mean is 75, standard deviation 7.55, and so on and so forth. Let me just double check that. That I have them all. Just going to go through my data and arrow over. I just clicked in and arrowed over, make sure I got them all there. And then I hit stem plot. So I click in the graph type and I hit stem plot, and I can see the layout of the stem. Here's my stem to the left, and then here's all the leaves. So it's kind of nice to be able to see, like I have 1, 2, 3, 4, 5, 6 values in the 60s and 6 in the 90s. So there's kind of like, if you were to turn this, you would kind of see the shape of like how a histogram would look. And then again, here's our summary statistics down there. And I'm going to give you a different kind of graph just while we're at it. Here's the histogram. See how it reflects sort of that same shape. One thing with histograms too, you need to notice, so this starts at 30, includes 30, and goes up to 40, but not including anything in the 40s. Okay. And it tells you how many values, 1. So this is really nice to get like your highest values. Where the dot plot, we had to like kind of count things up. Plus these are clumped by tens. I could do a width of 1 and get the individuals so I can see the mode, which we'll explore more later, but the histogram helps me get the mode. Right here that I have, remember this is including 94 and up to 95. So this would be, the mode is 94. All right, so we're gonna go out of that for now and back onto the PowerPoint. And we'll look at the next slide here, which is what we just did together. Not sure what that is down there. And then what do you notice? And we talked about some things already, but if you want to jot down a few more things that you notice, and you could try making some of those other graphs on your own, like using the making a histogram, for instance. So you could pause the video and do that, and then notice the summary statistics at the bottom of the page. So just take a minute to jot those things down. Other types of graphs you may see are frequency polygons or line graphs. We're not going to do too much with this. You can just do it in some kind of software. Saplet doesn't really do it very well. You can do it in just a regular Excel program, but it's kind of a pain to put in all your raw data. It's really easiest to make it a frequency table first, and we'll look at how to do that as well. But mostly we'll be using these for interpretation. The other kinds of graphs we'll see later are line graphs that have the regression analysis, which is with two variables. But for one variable, we don't often use this. We would use the histogram. So basically, this is the same as a histogram with just the midpoints plotted and lines drawn. Bar graph is rectangular bars. Again, this is more for categorical data, or sometimes we use it for like to have these proportions. We have our relative proportion there. And I have the horizontal axis has my age groups, and the proportion is on the side, which is the same as relative frequency there. So this has 3 age groups, users of Facebook, and the height. So I don't need to go into a lot of detail, but you can just see the younger is higher. Now it's probably, that was back in 2011. I'm guessing now it's probably older people. If you were to compare, older people are using Facebook, younger people, some of them still use Instagram, a lot use like TikTok and things. But I just want to give you an overview. And then in your homework and activities, you'll have more exposure to that, and there's videos that go along with that as well as needed. Here's a histogram. We will go through making one of these later, but here's some heights in inches to the nearest half inch of 100 male semi-professional soccer players. The heights are continuous data since height is measured, if you remember from chapter 1. So this is similar to a bar graph, but it's for quantitative data, and it will, like the bars touch, as you saw before. The vertical axis, it could be either frequencies or relative frequency. And we can go through making a quick one right now, but we'll do a lot more with this later. If you don't have the PowerPoint up or the worksheet to copy paste all this data, it's a big data set, then you don't have to do it along with me. You can just watch for this one, but you might want to try it. If you have that, just pause the video and try that. So I have Saplet up again, one quantitative variable single group, and it holds your last stuff. It won't save it from time to time. So if you need to turn something in for me for notes or an activity, project, whatever, then make sure you do a screenshot or use the snipping tool and cut out what you want to save. It would be a good idea. Here's my data over here that I just copied, but I have to make sure I reset everything. You can go back to the menu as well if you wanted to, but I'm just going to reset everything. And then I'm going to put in the data. And then I could put in my variable name is the heights I'm just going to be brief there. And then hit begin analysis. The dot plot always pops up first because that is the default. But you can kind of see the shape of it. And you can see the shape, but just individual values. So if we click histogram, then we get this frequencies on the side. So it goes up to 40. So it'll always kind of adjust, but you can set things differently. We can also make our widths bigger or smaller, and then it'll look different. So if I set the width to, like, say 5, that's really big, right? If I set it to like 3, but it's not too distorted, a little skewed over here, but we'll talk more about skewing later. If I did it as 1, you can see how it looks more like how the dot plot did. If we did like 6, it's gonna be really big. So 2 is what it picked, and that is a pretty good depiction there. And then we have the end value is 100, so you can double check that. Here's your mean, 67.26. Standard deviation, we'll talk more about later, 2.88805. I have this set to go out up to 5 values, but usually we, in general, the rounding rule of thumb is to round one more place than your data is given in. So we have whole numbers, so we would round to the 10th place for these. So we'd have 67.3 for the mean, 2.9 for standard deviation, so on and so forth. These other values here we'll look at more later, but minimum is 60, first quartile, which is the 25th percentile, is 66, median is 67, that's the middle value, halfway point if you were to sort them in order. Quartile 3 is 69.25 and maximum is 74. And that's called our 5-number summary, and we use that to create the box plots, and those are really good for comparing things. And it's just a nice visual in a little bit different way. It kind of gives that middle chunk of the data, and then it'll check for outliers as well. Let's see if we can even make a box plot right now. So we'll talk more about these later and do one specifically and talk about that and how to find the outliers and test them, because you always want to double check, but the step it'll do it for you. And you can even hover over and see the values. You can see what your quartiles are by hovering here. So this is the box. That's your first quartile, second quartile, third quartile there. These are your whiskers, which have your max and your min. So what happened here, because we had outliers, our minimum or whisker here changed. The fence is something we don't ever plot. I'll show you about fences later. But they are where we would indicate above or below the fence, the imaginary fence, are our outliers. And so now we're going to move on to look at just our histogram that we made. It's just a picture of it. And now we're going to look at time series graphs. If the value of a variable is measured at different points in time, the data are referred to as a time series data. Now, if you need to make one of these specifically for an activity, we'll go through that in more detail, but typically we're just going to be interpreting these. So the plot is obtained by plotting the time in which a variable is measured on the horizontal axis and the corresponding value of the variable on the vertical axis. Okay, now we're going to look at a frequency table. In a survey, 40 mothers were asked how many times per week a teenager must be reminded to do their chores. The results are in the data set below. Make a frequency table and a line graph. We're just going to do the frequency table for now, but we have this data set here, all the raw data, and you can sort that all out into a table. So we're going to look at the table. And here's the number of reminders in the left-hand column, 0, 1, 2, 3, 4, 5. So I just put that down the side, and then I tally up how many times I see them. So I have a 2, so I mark a line for 2. Have a 3, mark a line for 3. And you could do it that way and then total them up. So that way you don't miss any. You can kind of cross out as you go, or you could just simply try to find, okay, I have a 0 there, a 0 there. This is a small set, so you can see it easily. You could put it in something to sort the data, like the dot plot you could use, or even, the histogram with, value of 1, interval value of 1, and that would help out. So you don't have to go through that whole process. I've done that for you. I just want to give you a little tip. If you had to do this out by hand for some reason, you could do that. Now I've already got the frequencies over here, 2, 5, 8, 14, 7, and 4. And you can see here 3 times seems to be the winner. We would call that the mode also, like if we were saying what the most is. So that's our frequency distribution. We could change this to a relative frequency pretty easily. I didn't do that in this problem, but we could just take 2 divided by 40, and we would be able to figure out that would be 0.05, and we would say like 5% needed 0 reminders. So you can change it all to percentage as well. I've gone through and just grabbed that data and put it into staplets, and you can try that as well. And this is what I was saying, it helps you to figure out the numbers if you wanted to use that to get your totals, like 0 is 2, and then again I do have to count them up, but it's kind of easier than the other method. You can also, just as a note, you can get your summary statistics there. So you know your mean, your median, right here, your standard deviation, and all that as well. Let's see. Next one, measures of the location of the data. Median. The median is a number that measures the center of the data. You can think of the median as the middle value. We've talked a little bit about that already, but it does not actually have to be one of the observed values, because if you have an even number, then you're going to have 2 middle values. So you would average those. Half the values are the same number or smaller than the median, and half the values are the same number or larger than the median. So if we have this data set here, 1, 11.5, 6, 7.2, 4, 8, 9, 10, 6.8, 8.3, 2, 2, 10, 1. First, you've got to put them in order from smallest to largest, so you can go ahead and do that on your own. Pause the video if you need to. I've got that done here for you. And then you can just start ticking off the end. So like one way to do it is just kind of cross that 1 off, cross the 11.5 off, or just count into the middle. Like, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 14 values. So I am going to have 2 middle values. So I want to identify those. And I can see that it would be 6.8 and 7.2 right in the middle there. So the median is going to be between the 6th and the 7th value. So add those together and find the average or the mean. I'll go ahead and do that. And we get 7. So again, that's the middle value, even though it's really not one of the actual values. Okay, we're going to stop here for this video. The next section we'll look at is box plots in section 2.4. And I will cover that in a separate video to keep these under a half hour is the goal.